So we are going to start capacitors, okay? So what are capacitors? These are the devices, electronic components which stores energy, okay? Electronic components which stores energy. Okay. So see, basically now, battery also provides energy to the circuit. What is the work of the battery? It provides energy to the circuit. Then what is the use of capacitor? Capacitor also provides energy to the circuit, but first it stores energy and it provides energy in large amount whenever it is required. Like you can compare like suppose uh, like what you are doing, you are having a bath with the shower. Shower water is coming regularly. So shower you can compare now with battery. So shower water is coming regularly, okay, and you are bathing. Similarly, battery is providing energy regularly. But suppose what you do in a bucket, you first you store water, okay, and then you bath like this. One we do not sometimes we store water in the bucket and we bath directly at one go, okay. So this is like capacitor. So capacitor stores energy like bucket stored water. So capacitor also stored energy and provided instantly. One moment you bathed, okay. So battery is providing energy regularly, continuously. But capacitor, what it does? It stores energy first of all, and it provides energy when it is required in large amount instantly. Now, like your phone is also having capacitor. So phone is having battery also. So battery is running the system. Battery is running our phone. Okay. But when you turn on the flashlight, have you seen when you turn on the flashlight, large amount of energy is required. That's why our battery get drained. If you turn on the switch flashlight, na, our battery will get drained soon because it requires a lot of energy. Okay, like you are playing games or you are something heavy kind of things you are doing. So at that moment, large amount of energy is required. Like if you want to turn on the flashlight, large amount of energy will be required. So who will provide this extra large amount? This capacitor. There is capacitor in your phone. So these provide energy. Suppose you turn on the flashlight. So these capacitors provide energy which is required. Okay. So capacitor is a device which stores energy. Whether we can write basically electrical energy. Electrical energy. Okay. So see what is happening. Like suppose there is a hollow conductor, for example, hollow conductor. If I ask what is its potential at the surface, its radius is r, suppose. If I ask what is the potential of this conductor at its surface, so its formula is kq by r. No, kq by r, not r square, kq by r. So every capacitor we define one term, capacitance. Capacitance. What is capacitance? Charge holding ability per unit volt. What does it mean? That if you give 1 volt to the system, how much charge it can hold? Okay, if you give 1 volt to the system, how much charge you can hold, it can hold. So charge holding capacity per unit volt. Okay, we denote by letter C and its SI unit is farad. Correct. Now you see from here what we can see this equation. Can I write this voltage is directly proportional to charge or charge is directly proportional to voltage? Can I write? You see now, you increase the charge, voltage will increase, or you increase the voltage, charge on it, it will increase. Suppose this device charge is Q, its charge is Q. So we define potential at its surface as KQ by R. Now what you can see, if you increase the charge, voltage will increase. Or in different terms, we can say if you increase the voltage, this charge will increase, directly proportional. So charge is directly proportional to voltage. How much voltage you are providing? More voltage you provide, more charge it will hold. Okay. So we can define Q equals to some constant into voltage. So this constant is called now the capacitance. This constant is called the capacitance of the device. Q equals to CV. And from here, what we can write, C equals to Q divided by V. That's why I defined what is capacitance. Charge holding capacity per unit voltage. If you give one voltage, 1 unit volt, how much charge a body can hold? Okay. Okay. Next we have C. So although the formula like of capacitance is Q by V, but capacitance does not depend upon charge and voltage. Okay. See, if you increase the charge, voltage will increase. If you increase the charge, voltage will increase. If you increase the voltage, charge will increase. But capacitance remains same. Like suppose every student right now here has some capacity that you suppose, for example, you can learn 10 pages in a day. This is your capacity, 10 pages in a day. Suppose he has 12 pages in a day. For example, he can study 12 pages in a day. Now, if I increase the number of days, suppose 10 for you only, suppose take your example, that you have the capacity of learning 10 pages in a day. If I increase the number of days, 5 days, how many pages you can learn? 50. But still, if someone asks what is your capacity, capacity is 10 pages per day. You understood? So, capacity, if I say in your example, so number of pages divided by number of days. Okay. So what I told, 10 pages per day. 10 pages per day means in one day. This is your capacity. Now what I am saying, this capacity does not depend upon number of pages. This capacity does not depend upon number of days. Why? If you increase the number of days, like suppose number of days is 5. So number of pages that you learn, it will become 10 5s are 50. But if I ask what is the capacity, so number of pages divided by number of days. Number of pages 50, number of days 5. So again it is coming 10 only. See, it remains same. Means it does not depend upon this and this. Similarly, capacitor, this capacitance of a device does not depend charge and voltage. Rather, it depends upon, you can write here, it depends upon size and medium. It depends upon size of the device and medium. For example, first case that you have to learn, spherical capacitor. Spherical capacitor. So we have spherical capacitor like this. Its radius is R. So they will ask now, what is the capacitance of this capacitor? So the capacitance of this capacitor is 4 pi epsilon naught R. This value you should remember. 4 pi epsilon naught R. See, in the formula itself, is there any charge? Is there any voltage? It just depends upon size R. Epsilon naught means air, means it depends upon medium. And I can prove also. See, what I told, suppose this is charged. Suppose, for example, this is charged. This is a hollow conducting sphere. This is charged to Q. Its voltage is V. So what I told, what we can write about its voltage? KQ by R. So if I put here, so R will go there. So R will go there and K will come here. R by K equals to Q divided by voltage. See here. This R will go there, K is coming there. So R is going there, K is coming here. So Q divided by voltage. And capacitance is nothing but Q divided by voltage. So R divided by K. What is K? 1 by 4 pi epsilon naught. So this 4 pi epsilon naught will go up and it is coming 4 pi epsilon naught R capacitance. See. Now what is the most important thing? That it does not depend upon charge and it does not depend upon voltage. So this first formula you have to remember. Now few other things also they ask. You have to remember. I am not going to prove. Right now we don't have that much time. Just learn these formulas. Wait. कैसे यहाँ से ओके 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 So we have concentric sphere. You can see concentric sphere. This inside sphere we are charging. We are giving charge Q. And outside now we are earthing. This is called earthing. So they will ask what is the capacitance of this system. Just you have to remember. Nothing extra they will ask. Inside they are giving charge Q and outside they are earthing. The internal radius is A. The external radius is B. So they will ask what is the capacitance of this system. So 4 pi epsilon naught AB divided by B minus A. This formula you remember. Similarly, third they ask that same like this time they will, the external sphere they will give charge. Suppose we are charging the external sphere and we are earthing the internal sphere. This time same thing, everything same, internal radius A, external radius B. This time they ask, so you write 4 pi epsilon naught b square. B means external radius, b minus a. See, almost this formula and this formula is same. 4 pi epsilon naught, here also 4 pi epsilon naught. This is b minus a, b minus a. Here it is ab, here it is b into b. Here it is a into b, here it is b into b. B into b, b square. You can remember like this. Next. Okay. Next we have parallel plate capacitor. Parallel plate capacitor. So what you are doing? There are two plates, parallel plates. So what happens? You connect these plates to the battery. So what will happen now? If you connect this, you can, resistor is also there, but okay. So if you connect this plate to the battery, initially plate was what? Neutral. Any plate if you take, metal plate, so it is neutral, but it has electrons, it has protons. The electrons will get attracted to the positive terminal. So the electrons will leave this surface, electrons will start flowing like this. So if electron leave this surface, what will happen? It will become positive charge and these electrons will flow like this. Now what is the work of battery? What battery provides energy of this to this electron to flow from this side to this side, from positive to negative. Battery has some chemicals inside. What it does? It just sends this electron from this side to this side. Always remember. So electron will go here and finally it will get deposited here. Again one electron will go. So again this will become again this. So this becomes, see, this is positive charge and this is negative charge. So this is a parallel plate capacitor. Parallel plate capacitor means you will have two plates. One plate will be positive charged and one plate will be negatively charged. Okay. Achha, these plates now, this is 2D figure. These plates are like this. Correct. So if I see this portion, this is the area of the plate. This is the area of the plate. So area of the plate is A, suppose. And this is the distance between the plates, D. This is the distance between the plates, D. So you remember the formula. What is the capacitance of parallel plate capacitor? So capacitance formula is A epsilon naught divided by D. Okay. Few more things they ask. Because this is positive charge, this is negative charge, there is electric field established. Electric field is always from positive charge towards the negative charge. This is an electrostat. Electric field always go away from positive charge and comes towards negative charge. So this is the electric field between the plates of capacitor. So electric field I will be denoting by E. Now see, if someone asks what is the electric field between the plates, they ask, the one question they ask, what is the capacitance? A epsilon by D. Always remember, the electric field between the plates is sigma by epsilon naught. Sigma by epsilon naught or Q by A epsilon naught. If someone asks that what is this field value, E value, So sigma divided by epsilon naught. Sigma is what? This plate is charged now. Yeah, this plate is basically charged. So sigma is surface charge density. Means how much charge it is having divided by how much area. This is called surface charge density. Charge divided by area. So what I'm saying, electric field is nothing but sigma by epsilon naught. Sigma is charge divided by area. If someone asks what is the voltage difference between the capacitor, plates of capacitor, what is the voltage difference here? Voltage difference. So remember this word again, Ved. That voltage difference between the plates of capacitor, or directly we write V. V means voltage difference. Ved you remember. E multiplied by D. D is what? Distance between the plates. So E formula is sigma by epsilon naught into D, or this E formula was Q by A epsilon naught into D. So someone asked what is the potential. So you have to remember this formula. Now, in conductors, we have the concept of dielectrics. Dielectrics. What happens? See, suppose there is any medium, like this is dielectric medium, for example. This is a dielectric medium. In conductors, we had this concept. That's why I'm not going much depth. But what I'm saying, suppose there is some electric field outside. And this is a suppose kind of semiconductor. Not very good conductor. Dielectrics are not very good conductors, but not insulated. But like semiconductor, you can feel. Non-conductors only, you can feel like, but not a conductor, very good conductor. So what happens? This conductor, as electric field is established, this is neutral. Right now, this plate is neutral. This medium is neutral. Due to the external electric field, the electrons of this material stick to one plate. Because I told positive charge moves in the direction of electric field and negative charge moves opposite to the direction of electric field. Now, due to establishment of this positive and negative charge, there is inside electric field which we call E induced. So, what we can see, if someone asks what is the net electric field here in this zone. So, net electric field is external electric field minus induced electric field in some less value. Like suppose this is 10. E induced is how much? Suppose 5. So what is the net electric field we will getting? 10 minus 5, that is 5. This is the net electric field. Now we write like this also, net electric field equals to external electric field divided by one factor which is called dielectric constant of the medium. Like in this case, can I write net electric field? Net electric field was how much? 5 equals to external electric field, that is 10 divided by 2. 10 by 2 is what? 5. So this 2 will be the dielectric constant of this medium. This 2 is the dielectric constant of the medium. What it tells? By what factor electric field will be reduced? If someone asks now what is the dielectric? Dielectric of any medium tells that by what factor electric field will be reduced. External electric field will be reduced. So always remember, external E net, what we get finally equals to external electric field divided by K, that is dielectric constant of medium. Now, why I am teaching this? Because what they do, they will say that there is a capacitor, parallel plate capacitor. This has been charged already. Area of the plate is A. Distance between the plates is D. So if I ask what is the capacitance of the system, so A epsilon naught divided by D. This is the capacitance of parallel plate capacitor. If electric field, they told that electric field is E. Voltage, they say that the voltage difference between this is V. As I gave you this formula also, electric field formula sigma by epsilon naught. Voltage formula Ved, electric field multiplied by distance. Electric field is sigma by epsilon naught multiplied by distance. Okay. Now what they will do now? They will insert dielectric medium. So there is dielectric medium, suppose here inside. So inside they are inserting one dielectric medium having dielectric constant K. Dielectric constant K. Now they ask what will happen. So now new electric field E dash I am writing, or final electric field after inserting dielectric. What will happen? It will reduce by K times final electric. Initial electric field was there, na? Initial electric field was there. How much? This much. Now what will happen? Electric field will be reduced by K times final electric field. Similarly, final voltage. Now, since voltage depends upon electric field, V equals to, and electric field is reducing by a factor of K. So voltage will also reduce by a factor of K. So voltage will also become V, if initial V was the voltage, so V by K. Acha, if they ask what happens to capacitance, capacitance always remember it increases by K times. Final capacitance, I am not proving, final capacitance becomes K times initial capacitance. Means now it will become K times A epsilon naught divided by D. Achha, one thing I missed, energy of the capacitor, energy of any parallel plate capacitor. So energy of any parallel plate capacitor formula is Q square by 2C, or we have three formulas, half CV square or half QV. Half QV. Half QV. This is the energy of any parallel plate capacitor. Now see what is happening. This is the energy. If someone asks now what is the energy of a capacitor, Q square by 2C, half CV square, half QV. Now if they say that if we insert dielectric, what will be the final energy? So see, since we are not doing with nothing with charge. Suppose the charge was Q here. So charge, final charge will remain same. Charge will not change. Final charge will be Q only. Okay. Charge will be Q only. So energy, final energy if they ask, so it will become Q square by 2C. Now capacitance has increased by K times. So in denominator it will be K times, means energy. Can I write Q square by 2 times final capacitance, and final capacitance has become K times initial capacitance. So can I write 1 by K times Q square by 2C, and Q square by 2C was initial energy, means final energy becomes also 1 by K times. Okay. So these things they ask normally. Then we have series combination and parallel combination. So series combination, like capacitors will be in series, like this. What is the meaning of series? Series means like here in resistors, current is same. Here charge will be same in all the capacitors. Like here Q, here also Q minus Q, here also Q minus Q, here also charge will be Q minus Q. Suppose this capacitance is C1, its capacitance is C2, its is C3, its C4. Voltage difference will be different. Suppose here voltage is V1, just like resistors, V2, V3, V4. Same. Their current remains same. Here charge remains same. Here this capacitor also charge is Q. This capacitor also charge is Q. Achha. But here formula is just opposite. Here if someone asks what is C equivalent. So for series, what we write 1 by C equivalent equals to 1 by C1 plus 1 by C2, like this we write. Means if we have two capacitors, so we can write C equivalent equals to C1 C2 divided by C1 plus C2. Parallel combination. Parallel combination. So like this capacitor and this capacitor. Between same potential difference. You can see, suppose I connect like this, for example. So I told now, if V volt battery is there, what you can take this 0 volt, this you can take V volt. If potential difference of the battery is V. So if this is 0, this will be 0, this will be 0, this will be 0, this will be 0. This will also be 0. If this is V, this is V, 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 here also V, here also V. So what you can see, first capacitor is also having potential difference V minus 0, V. Second capacitor is also having a potential difference V minus 0. Same potential difference means they are in parallel. Suppose its capacitance is C1, its capacitance is C2, then what will happen in this case? C equivalent someone asks, so C equivalent will be C1 plus C2. Always remember the potential difference across first capacitor is equals to the potential difference across second capacitor. Acha, if some charge Q is flowing from the battery, what will happen? It will go like this, it will go like this, it will go like this, it will come here. Some charge will go there, Q1, and some charge will go there, Q2. Means what we can write? Out of Q, some charge went to first branch and some charge went to second branch. Okay. So sometimes they ask this question, how much charge is flowing inside a capacitor? So you can use this formula, and you know one more thing, potential across first capacitor equals to potential across second capacitor. So potential across first capacitor, what you can write? See, Q equals to CV. So V equals to Q by C. Q equals to CV. So V equals to Q by C. So can I write potential across first capacitor Q1 by C1 equals to potential across second capacitor Q2 by C2. Using these two equations now, we can find the charge, because they ask what is the charge on the capacitor. Okay. Example I am taking so that you understand. This is C1, this is C2, this is C3. Capacitance 1, 2 farad, suppose 2 farad. This is 4 farad, this 3 farad, this battery is 10 volt. They will ask what is the charge on each capacitor. Okay. How to do? See. So first find C equivalent. Since they are in parallel, 4 plus 2, 6, and 6 and 3 are in series. So 6 and 3 are series means 6 into 3 divided by 6 plus 3. 6 3 is 18 divided by 9. So 2. Correct? Means you can draw equivalent like this. Like 2 plus 4, this is 6. Then this is 3. 10 volt. Then finally you can draw 6 3 equivalent 2 and 10. Well, if someone asks how much charge is flowing from the battery, so charge equals to C equivalent into voltage. How much charge flowing from the battery? C equivalent into voltage. C equivalent is 2, voltage is 10. So Q equals to 20 coulomb. So 20 coulomb charge is flowing. Means here 20 coulomb charge is flowing. So because they are in series, here also 20 coulomb will flow and here also 20 coulomb will flow. Means how much charge is flowing in this? So answer will be 20 coulomb. How much charge is flowing across this? 20 coulomb. Means, see here, this 20 coulomb charge from the battery was 20 coulomb, na? 20 coulomb, 20 coulomb, 20 coulomb, 20 coulomb here like this. It reached. Some charge will flow here. Suppose this is Q1. Some charge will go there. This is Q2. Now we know that this Q1 plus Q2 should be 20. Out of 20, some is going in this branch, some is going in this branch. What we can write? Q1 plus Q2 equals to 20. Achha, you know one more thing. Potential difference across this equals to potential difference across this. So V equals to, see, Q equals to CV, V equals to Q by C, means Q1 by C1, that is 2, equals to Q2 by C2, that is 4. Solving these two equations, we can get Q1 and Q2. Q1 means how much charge in this capacitor, Q2 means how much charge in this capacitor. Correct. So these kind of questions also they ask. One more thing they do, partial dielectric. Partial dielectric. Partial dielectric. Like what they will do now? This capacitor, this is one plate. This is one plate. Some thickness, some distance, they will put one medium, dielectric medium, not the complete, till here. Suppose this dielectric value is K1. Next, another dielectric medium. Its dielectric constant is K2. And the remaining is air. The remaining portion is air. This length was T2. This length was T1. Total length distance between plates they give D. Correct. Achha, what will the length of remaining portion? Total is D minus this plus this. T1 plus T2. Now, how to write the C equivalent of this system? See here. This is plus Q charge, this is minus Q charge. C equivalent is given by direct formula I am writing. A epsilon naught divided by, what you have to do? You have to write the thickness divided by dielectric constant. So thickness is T1 divided by dielectric constant K1 plus again thickness is T2 divided by dielectric constant K2 plus again thickness is T minus T1 plus T2 divided by its dielectric constant. Now for air dielectric constant value is 1. For air dielectric constant value is 1. I am writing K value for air is 1. K value for metals, it is infinity. So we have this formula for partial dielectric. Okay. Sometimes what they do, they give this like scenario. They feel the dielectric like this. Some portion, some length x. They give the entire length of this plate L. They will give the width of the plate. Width of the plate means suppose this plate is like this. So width of the plate, suppose B. Understood what I am saying? Till here this length is x. And they have field dielectric here till x height. Downward there is nothing. They will ask what is the C equivalent of the system. So see how we solve this. We will take first system. You will draw the figure like this. And in parallel you take the downward. Here only air is there. Na? So you consider that it is composed of two capacitors. One up, one down. One up, one down. And they are in parallel. So this capacitor is filled with dielectric. So you make like this. But this capacitor is not filled with any dielectric. This capacitance you write capacitance C1. This capacitance you write C2. So what will be C equivalent? Because they are in parallel. C1 plus C2. Now the main concern is what is C1, what is C2. So C1 is capacitance formula A epsilon naught by D, area. Now area of this portion, one is this capacitor, na? One is this capacitor and second is this capacitor. So area of this capacitor, area is this multiplied by this. So x multiplied by B, A, this is area, epsilon naught divided by distance between plates D. Suppose the distance between the plates is D only. So A epsilon by D multiplied by, because dielectric is also there. So multiplied by dielectric constant K. Suppose its dielectric constant is K. This is C1. What will be C2? Downward area. This area we have taken. Downward area. Achha, if this is X, total length is L. So this length will be what? L minus X. So its area will be L minus X. This is length multiplied by breadth. Multiplied by breadth. So A epsilon naught divided by distance between plates D into 1. And you can do C1 plus C2. Okay. One more thing. Sir will take class now. Here.
After this 7.
Here only. Okay. 5 minutes I will take. Connection of capacitor. Suppose there is one capacitor which you have already charged. Already it is charged. How much? Suppose the charge is Q1 like this. This is positive plate, this is negative plate. This is positive, this is negative. There is another capacitor. This is already charged. This is also already charged. Its charge is Q2 minus Q2. This is positive plate, this is negative. Now what you do? You connect them. And how you connect? Positive, positive you connect together. Negative, negative you connect together. This capacitance value was C1. This capacitance value was C2. Initially, before connecting, what was the voltage across this capacitor? So Q equals to CV, V equals to Q by C. Voltage was how much? Q1 by C1. If someone asks what was the voltage initially, Q1 by C1. What was the voltage of this capacitor? Q2 by C2. Correct. Now, but after you connect, after connection, if they ask what is the, now what will happen? Now, if you connect these two, they will have a common voltage. They will have a common voltage. If you connect these two capacitors, now they will have a common voltage. Why? See now, suppose this is, you have connected with wire. So this potential is suppose X. This potential will also be X. This potential is Y. So this potential will also be Y. So what is the potential difference? X minus Y. What is the potential difference? X minus Y. Means after connection, they will have a common potential. So they ask what is the common potential. You do like this. You remember one formula. You know that Q equals to CV. So V equals to Q by C. Correct. So V common equals to Q net divided by C net. You write. Now, if they are connecting positive with positive and negative with negative, so Q net you write Q1 plus Q2 and C net you write, because they are in parallel, C1 plus C2. This is the common potential. Okay. Q1, what you can write? Q1 equals to C1 V1. Q1 you can write from here. Q1 equals to C1 V1 plus Q2 equals to C2 V2 divided by C1 plus C2. Achha, there is some loss of energy in this case. They ask this also. You remember this formula, half C1 C2, C1 plus C2, V1 minus V2 whole square. This is the loss of energy. If you connect now, there will be some loss, heat loss. They also ask this question. We have direct formula. Very important point. If they reverse the direction, means positive plate, they connect with negative plate. Like this is positive plate and this is negative plate. So positive plate, they connect with negative plate, and negative plate, they connect with positive plate. Like this. All other things same. Means initially this was having charge Q1, initially this was having charge Q2, initially capacitance was C1, this capacitance was C2, its voltage was V1, its voltage was V2. So they will ask what is V common? Common voltage after connection. So here Q1 plus Q2 you have done now. There you do Q1 minus Q2. So this will be Q1 minus Q2, C1 plus C2, or C1 V1 minus C2 V2 divided by C1 plus. And second, they ask loss. In loss, only one change you do, half C1 C2, C1 plus C2, V1. Now here you do plus V2 whole square. What you can see? Here you are getting more loss. See na plus, here it is minus. Here you are getting more loss when you connect positive and negative. This is called unlike polarities connected. Unlike, positive is connected with negative, unlike polarity. And this is called like polarities connected. So we get more loss in unlike polarity. Here more loss. Sometimes what they will give? They connect one charged capacitor with uncharged capacitor. Uncharged. You will see the questions, NEET PYQs. They are connecting any one charged capacitor with uncharged. So in that case, what you have to do now? The second capacitor is uncharged. So Q2 will be what? 0. It is not charged. So make Q2 0. So in all the places, Q2 you have to take 0. Correct? If one of the capacitor is uncharged, again I am writing, if one of the capacitor is uncharged, then take Q2 equals to 0. And same formula you apply, there will be no changes in any other formula. Here 0, similarly here also 0. Okay, but C1 plus C2 will be there. Just Q2 value you have to take 0. Okay, so that's all about capacitor, important formulas. Okay, revise these points. It is covering almost 90% of the points. Okay, thank you.